Hi folks. Today we're working on scale factor. So this is the lesson where we start to change the size of the object. In all the other lessons we haven't touched the size or the shape of it. We've just changed where it's located, the direction of it. And so now we're dealing with scale factor. FYI, you did do scale factor in grade 9, but not all classes got to this lesson. So some of you will know this already, some of you will have no clue, and that's okay because we're reviewing it here. Okay, so a scale diagram is usually smaller than the original. And when it's smaller, we call that a reduction. Okay, it's just, we're shrinking it. Think of a photocopier. We're just reducing the size of the original object. So the fraction that is used to find the scale factor for a reduction is the same fraction if we do an enlargement. So this is our formula. We always put, scale factor has no units of measure. So we do the length of the scale object. Sometimes we'll call that the drawing. But the most important thing is that the original goes on the bottom, okay? In this case of a reduction, the scale factor will be less than 1. It'll be a decimal or a fraction, okay? So if it's a reduction, the scale factor will be less than 1. Okay, if it's an enlargement, the scale factor will be greater than 1. Kind of works both ways, makes sense. You want to double something in size, the scale factor is going to be 2. All right, so here we go. Example number 1, we're going to calculate the scale factor. So it's given us the measurements, diameter 3 inches, diameter 1 inch. So here's my reduction. So scale factor is reduction or drawing, whatever the resulting image is, over the original. So the scale factor will be, the reduced image is 1, and we're putting the measurement in, so 1, and the original image was 3. So the scale factor for this is 1/3. Now you could change it to a decimal if that makes you more comfortable. If you choose to do that, make sure you put that repeating line on there, and we're going to do some calculations with scale factors as well. So just if you're using the decimal and it's a repeating decimal, because sometimes that happens, you've got to use more than just 0.3. You got to put a bunch of 0.3s in there. Please and thank you. All right, so let's move on to example 2. The scale for the image of the totem pole to the right is 1 to 85. The height of the totem pole is 1.5 meters. Okay, I'm going to go back up to the top and I'm going to give you two more formulas. All right, if we want to find the original size, so if we want to find the original length, we are going to take the length of the scale object. I'm going to call it the drawing, and we're going to divide it by the scale factor. Okay? You want to write these formulas in. If we are trying to find the drawing length, so the one that we've either reduced or enlarged, we're going to take the original length and we're going to multiply it by the scale factor. I ran out of room there. So these are 2 additional formulas that are super helpful because then you don't have to really worry about the algebra in it. All right, so when it's given like this as a ratio, really what it's saying is 1/85. Oops, I didn't slide up for you guys, sorry. Again, if I'm going too fast, I'm in the room by myself, so if I'm going too fast, definitely pause the video if you need to get those formulas copied down. You can go back, scroll through, or check the notes. They'll be online as well. All right, so our scale factor is 1/85th. So this picture is 1/85th as tall as the original. So if the height of the totem pole, so we know the original is 5.1 meters, and that's not feet, ladies and gentlemen, that's meters. So somebody who is 6 feet is close to 2 meters. So we're looking at a totem pole that is over 12 feet high, okay? So just keep that in mind. Even if you've ever had an opportunity to see totem poles, they're pretty amazing in person. So the scale of this pretty picture is 1/85. If the original was 5.1 meters, how tall is the scale image? So I'm going to slide back up to my formulas. I'm trying to find the drawing length because I know the original length and I know the scale factor. So the drawing is the original length times by the scale factor. And I'm just abbreviating it SF because I want to. All right, now this is in meters. This is in meters. So anything that we get is, my answer is going to be in meters as well. Okay, so the first thing I'm going to do is I'm going to take 1 and divide it by 85. I'm just going to get that decimal there. That's kind of an ugly decimal. I don't need to write down the decimal. Then I'm going to times that by 5.1. My calculator will pull the answer from the other line. There is an answer button on most scientific calculators. All right, so 0.06. So the drawing has a length, or a height, sorry, of 0.6 meters. So meters here, that means my answer will be in meters. And units of measure are super important. Now, if we wanted to convert that to centimeters, we'd go back to our conversion charts. Remember the one I screwed up on? I'm just going to my metric. If we want to change that to centimeters, we know that we're going meters to centimeters, so we're going down 2 steps. So we're timesing by 10 for each step. So now this question didn't ask you to convert, but what I'm doing while I'm recording these lessons, we're in the conversion unit, so that's why I did it. Okay, if the wingspan across the reduced totem, so we know the drawing this time, is 3.5 centimeters, what's the actual wingspan? Oh, sorry, this shouldn't be here. Move that down, imagine that in your mind, that it's moved down. Okay, so we're gonna do some math. I'm gonna slide back up. We're trying to find the original length, and we take the drawing length and we divide it by the scale factor. Drawing length divided by scale factor. So for the original, that is the drawing divided by the scale factor. So we've got 3.5 divided by 1/85. All right, so we have that decimal, and in my calculator I can do this. I can go 3.5 divide by, open up a bracket, and say 1 divided by 85 and close my bracket. And it will do the math for me. So this was in centimeters, so my original will be 297.5 centimeters. If I want it in meters, I'm going to divide by 100, or divide by 10 twice. So you can do that there. Okay, I'm going to flip the page, but I got to read this first because this is the instructions. Use a scale factor of 0.5, so it gave me the 0.5, and draw a scale diagram of the object below. So it's giving me the scale factor. So now I'm not doing any math, I'm going to draw a picture. Oh dear. Okay, so I'm just going to remind myself that the scale factor is 0.5. All right, so if this is the original, all I have to do is times these lengths by 0.5 to get the drawing. So 1, 2, 3, 4, 5, 6, 7, 8. So that's 8. This one's 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. That one's 6. 1, 2, 3, 4, 5, 6. That one's also 6. That's 2. And this should be 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10. All right. I have to take a minute to draw, to figure out what they are, because I need to times 8 by 0.5. So really, all that means is I'm taking half of 5. So half of 5 is 4. So my new height will be 4. 1, 2, 3, 4. All right, so this one is 4, so it's going to times by 2. Oops, sorry guys. Times by 2, or sorry, times by a half is 2. 6 now turns into 3. 6 now turns into another 3. 2 turns into 1. 10 turns into 5. And that's my reduced drawing. So again, I'm taking 8 and I'm timesing it by the scale factor, and that gave me the height of, oh sorry, you guys can't see that. 8 times by the scale factor gave me 4. This one times by 0.5, that gave me the 2. 6 times 0.5 gave me the 3. Times by 0.5, that gave me the 3. 2 times 0.5 gave me 1. 10 times 0.5 gave me 5. So that's my drawing. Okay, moving right along. As you can see, the pages got spaced out a little bit, which I think is kind of a problem, but not a problem. We'll figure it out. So this time we're going to do an enlargement. We really haven't talked much about enlargements, but we're doing the same thing. If this is the original, we have a scale factor of 3. What we're doing is we're just, I forgot the L in original. We're taking the original lengths and we're timesing them by 3. So I'm going to go around and I'm going to measure this. So that's 3 units. 1, 2, 3. That's 2. That's 1. That's 2. That's 2. And that's 1, 2, 3, 4. Okay. So that means I take 3 and I times it by 3. And that should give me 9. So my new object is going to be 9 high. So start there. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it should be right there. See, I have to count them out. Some of you will just be able to see it. So we know that that one's 9. 2 times 3 gives me 6. So 1, 2, 3, 4, 5, 6. All right. 1 times by 3 is going to give me 3. 1, 2, 3. And then 2 times by 3 is another 6. 1, 2, 3, 4, 5, 6. 2 times by 3 again is 6. So 1, 2, 3, 4, 5, 6. And 4 times by 3 should give me 12. Now this should go right back to where I started from. And I'm just going to count to make sure it's 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Beautiful. So it all worked out. That's good. Because you know drawing's not my strong suit. So that's all we're doing today. I find those 3 formulas super helpful. I would definitely put them on my cheat sheet for the test for this. And yeah, if you have any questions, please let me know.